Hi students, welcome to our science class. I'm teacher April Joy Ando and today we're going to discuss about convex and concave lenses. So this is a topic in quarter 2 module 6. Are you ready to learn? Let's take a look at the milk. The milk is the most essential learning competency. Now for this topic, our milk is to predict the qualitative characteristics of images formed by plane, mirror, curved mirrors, and lenses. Now let's take a look at our objective. So our learning objective is to describe the characteristics of images formed by lenses using ray diagrams. So we will know how to do ray diagrams later on, and at the same time determine the different characteristics of the images formed by these lenses. So that's exciting, isn't it? So what are the materials that you will need? So you need to prepare the following. Grade 10 Science Quarter 2 Module 6. You also need a clean sheet of paper, pencil with eraser, ruler, and an Android phone. Or you may also have your laptop with you should you wish to download this lesson video on your phones or laptop and watch it anytime, anywhere. Now, let's play a game. This game is a very familiar game to you all. Most of you have already played this game over and over again. So the game is called 4 Picks, 1 Word. So I will be showing you 4 pictures and you will guess the common word among all these pictures. So we will have 3 sets or 3 rounds, and each round you will be given 5 seconds to guess the word. Are you ready? Let's start. So the first 4 pictures. Okay, look at each picture here. What do you think is the common word, common thing among these pictures? So you have letter R as the hint. Okay, so try to guess that word. So I'll give you 5 seconds and it starts now. Okay, any guess? You have letter M. So the word starts with M and ends with R. What word could that be? Now let's take a look at the second letter. It's I. What word is this? Anyone who can guess? Okay, I hear somebody said mirror. How do you spell mirror? Let's see. Okay, it has an R. What could be the next letter? It's another R. So the missing letter would be O. That's correct. So the correct answer here is mirror. So I hope everybody got it right. Congratulations! So now we're ready to go to the next round. So you have 4 photos here. What do you think is the common thing among these 4? Can you see or spot that similarities? Okay, so I'm giving you 5 seconds to think of the word. Okay, time's up. What could be that word? Okay, you have an I and another A there. So you have still 3 letters to guess. Let me give you another letter. Okay, you have an M. So what would be the next 2 letters, the last 2 letters? Anyone? What's your guess? Okay, I hear somebody said image. Let's see if the answer is image. So you have G. What's the last letter to complete the word image? Okay, E. So the correct word here is image. So congratulations if you get the answer correct. So now we're ready to proceed to the last round. Okay, try to guess this right so that you can get a perfect score for this game. So you have another set of pictures there. You have a magnifying glass or lens here. You have a camera. You have eyeglasses like mine. I have also, and I'm wearing my eyeglasses. And then you have here a microscope. What do you think is common among these pictures? So I'll give you 5 seconds and it starts now. Time's up. So you have N there and L. So the word starts with L. You have 2 more letters to think of. What could be this word? What is common among all the 4 photos? Anyone who can guess? Okay, let's look at the next letter. It's an E. Len. What could be the missing letter here? Okay, so it's S. The correct word is lens. Congratulations! So now I'm showing you questions. Let's proceed. Question 1. What are the 2 types of curved mirrors? A. Circle and convex. B. Convex and cylindrical. C. Plane and concave. D. Convex and concave. What could be the correct answer here? Do you have an answer already? Let's reveal the answer, the correct answer here. It's letter D, convex and concave mirrors. Did you guess it right? Very good. So now let's go to the next question. Question 2. Ray diagramming is useful in locating the image formed by mirrors and lenses. Which qualitative characteristics can be described by ray diagrams? Is it A. Location, orientation, size, and type? B. Location, operation, size, and type? C. Location, orientation, size, and tape? Or D. Limitation, orientation, size, and type? Okay, think of the answer. Do you have an answer? Okay, so now let's find out which one is the correct answer. Okay, it's letter A, location, orientation, size, and the type of image. So now for the last question, question 3. A magnifying glass consists of a lens that lets the observer see a larger image of the object. What is a lens? A. It is an opaque material that reflects light. B. It is a transparent material that doesn't allow light to pass through. C. It is a transparent material usually made of plastic or glass that allows light to pass through. D. It is a material that blocks light. So which one is the correct answer? Do you have an answer now? Let's see if you guess it right. The correct answer is C. Lens is a transparent material usually made of plastic or glass that allows light to pass through. So how many correct answers did you get? Wow! Now you're ready to learn new things, new concepts. So now we will go to our lesson proper, and remember that our objective for today is to describe the characteristics of the images formed by lenses using ray diagrams. So now let's talk about lenses. So there are 2 types of lens, but first let's take a look at the optical instruments here. So you have a microscope, a magnifying glass, you have a binoculars, and then you have a telescope. So all of these optical instruments consist of lens or lenses. So in biology, we make use of the microscope to view or magnify microorganisms. We use this to look at cells. And then telescope in physics or in astronomy, we make use of this to view things that are distant, view things afar, make it closer and bigger. So these are made up of lenses. So now let's know more about lens. So there are two types of lens. First, convex lens. The other one is concave lens. So kindly tell something about these lenses. Look at these pictures. What can you say about the shape of the convex lens compared to the shape of a concave lens? Is there a difference? How about in terms of the behavior of light? Okay, assuming that these arrows in the pictures are the light rays, how do these light rays behave as it pass through the lens? Is there any difference? Okay, so I think you have an idea in mind now. So looking at the shape for convex lens, you have a shape similar to an oblong. So you have a wider, thicker center or middle part of the lens, and then the edges are thin. While in concave lens, you have a thinner middle part, and then you have thicker edges. So it's the opposite. Now, how about for the light rays? So observe that for the two types of lenses, convex and concave lens, the light rays, what's this, bend or refract as it passes through the lens. So there is refraction of light or bending of light. Now, let's focus first on convex lens. So let's see how light rays behave in this type of lens. So for convex lens, you have light rays passing through the lens. As it passes through, it bends or it refracts, as you can see. So these light rays meet or converge at the focal point or at the focus. That is why convex lens is also called a converging lens. While for a concave lens, you notice that the light rays upon entering the lens spreads out or diverge. So the word is diverge. That is why a concave lens is also called a diverging lens. So again, converge means to meet. That is for convex lens. And then diverge means to spread out or to scatter. And this is for a concave lens. So now let's talk about the different parts of a lens. We will also be discussing about the parts that make up the ray diagram since we are about to discuss ray diagramming for lenses. So it's important that we all know this. So first, this is a convex lens or also known as converging lens. So again, you have a convex lens with thicker middle part and thinner edges. So looking at this green arrow here, it represents the object where the light rays will come from. And then you have the principal axis. It's a straight horizontal line passing through the center of the lens. Then you have letter F, which means focus or focal point, where the light rays usually converge. And then the vertex or the optical center is the center of the lens. So you may have noticed this that other references would use letter V for vertex, while the rest use letter O for optical center. So still they're the same meaning. They are the center of the lens. So you may use either vertex or optical center, but in this lesson, we will be using vertex instead of optical center. So it's letter V. So next we have the focal length. It's the length from the vertex to the focus. So it's the distance between these 2 points, focus and the vertex. And it's the same distance from the F to 2F. So these are the parts for convex lens. Let's take a look if they have the same parts or differences for concave lens. So for concave lens, which is also known as diverging lens, This type of lens has a thinner middle part and thicker edges. So again, we have this green arrow which represents the object. It is placed in front of the lens where the light rays will come from. And then you have the principal axis. It's a straight horizontal line passing through the vertex or the center of the lens. F stands for the focus or focal point. And then you have the vertex or the optical center of the lens. And you have focal length. It's the length or the distance from the vertex to the F. So same distance from F to F. And same focal length on the other side of the lens. So these are the different parts of the lens and the ray diagram. Let's talk about ray diagramming in lenses. So you will construct ray diagrams, and at the same time, let's describe the location, orientation, size, and type of image formed by convex and concave lenses. So get ready with your paper, your pencil, and ruler. Let's start. First example, we have for a convex lens, we will be doing the ray diagram. So this is the object here. The object is placed beyond 2F. So this is case 1. Object is beyond 2F in front of a convex lens. So look closely on how we're going to do the ray diagram. So first ray, a light ray coming from the tip of the object. It goes straight horizontally parallel to the principal axis. Then it bends and it passes across, or it bends downward diagonally passing through F. So you call this as the PF ray. The P stands for the principal axis. You have the F, which stands for the focus. And then the second ray is a light ray coming from the tip of the object, passing through F. Then it bends, goes straight parallel to the principal axis. You call this ray as the FP ray. Next, the third ray is the light ray that comes from the tip of the object, and it goes down diagonally passing through V, or the vertex. This is what we call the V ray or the vertex ray. Now, look at this point here. So this is where the three light rays will intersect or meet. So this is the location of the image. So the image is here. So later on, we will describe the characteristics of this image. By the way, for ray diagram, I'm showing you three rays. But in our next exercises or examples, you can actually use only two rays, two light rays, for as long as there is intersection of points where the image is located. Let's take a look at our next example. Okay. This is case 2 where the object is placed at 2F. So you have a pencil, which is the object placed in front of the convex lens at 2F. So how will our ray diagram look like? So you get your paper, pencil, and ruler and draw the ray diagram of this convex lens following the procedure I have discussed with you earlier. And I'll give you only 5 seconds to do that. Then timer starts now. Okay, time's up. Let us compare the ray diagram here with the ray diagram that you have drawn on your paper. So the first ray is a light ray parallel to the principal axis. Then it goes downward passing through the F. And then the second light ray is a light ray that goes diagonally straight passing through the vertex V. Now I have used here the V ray because it's easier to draw. Okay, so I have only drawn two light rays. So point of intersection would be here. So that means the image is located here. And you draw it like this. The image is here. Okay, so later on we will describe this image. So we have already two examples for convex lens. Let's have an example for concave lens. So you have case 1 here, the object is beyond 2f. So this is the object placed beyond 2f in front of a concave lens. So how do we draw now the ray diagram? So ray 1, so it's a light ray, okay, drawn from the tip of the object parallel to the principal axis, and then it bends. But as it bends upward, it refracts upward, and once you extend the light rays backward, it is passing through the focus. So this is what we call the PF ray. Again, P is the principal axis, F is the focus. So this is the first ray. The second ray is a light ray that is passing through F. If we extend this light rays here, it seems to pass at F, but it stops there at the center and goes straight parallel to the principal axis, and you can extend it backwards like that. Okay, so this is the FP ray. So focus principal axis ray. And then the third ray is a light ray drawn from the tip of the object passing through F, or V rather. So by the way, this is V. So vertex. So it's just one straight light ray passing through the vertex V. So this is what you call the V ray. So you have three light rays now meeting at this point here. So this is where the image is located. So you can draw the image like that there. So once again, in our next example, you can make use of two light rays. So you just need to pick if you're going to use the PF ray, FP ray, or the V ray. So pick only two. So let's proceed to the next example. So this is another concave lens where the object is placed between 2F and F. So this is 2F, this is F. So the object is in between. So now, following the steps I have provided to you earlier, make the ray diagram of this concave lens. Okay, choose only or pick only two light rays and locate the image. I'll give you 5 seconds and it starts now. Okay, so let us now show the ray diagram. So you just compare your answer to this. Okay, so you have light ray. So it's a light ray parallel to the principal axis, then it bends upward. Then if you extend this downwards, it will pass through F. And the second light ray that I'll be using is the V ray, because this is the easiest to draw. So the V ray here is a straight light ray passing through the center of the lens. Do you see intersection of the two light rays? Yes, of course. So the two light rays meet somewhere here. So this is where the image is located. We can now proceed to determining or identifying the characteristics of these images. So let's go back to our first example. This was our first example earlier. Case 1 where the object is beyond 2F. So the image is here. So what can you say about the LOST of this image? So again, L means location, O means orientation, S means size, and T means the type of image. Okay, so looking at this image here, the location is between F and 2F. Orientation is inverted. Why inverted? Because the intersection happens below the principal axis. What I mean is the three light rays meet somewhere here just below the principal axis. So it's inverted image. the size of the image compared to the size of the object is reduced or smaller. And then the type of image is real. So this is a real image formed by this convex lens. So notice that we did not use any extended light rays here. Okay, so again, beyond 2F, if the object is beyond 2F, then the location, orientation, and size, and the type of image would be this for here. Okay? And you can easily, state this characteristics once you know how to draw ray diagrams. So let's now proceed to next example. So this is our second example, the ray diagram for convex lens where the object is placed at 2F. So what do you think is the LOST of this image? Okay, so the image is here. So the LOST would be, let's go back to that. So the LOST would be, okay, LOST. So the location of the image is at 2F. Okay, it's clear there, huh? It's at 2F. Orientation, inverted or upright. So it's inverted. Inverted because the image is formed below the principal axis. Compared to the size of the object, is the object same size, smaller, or bigger? So it's the same size. Same size. And then the T, or the type of image, it is a real image. So these are the LOST for the image formed by the convex lens where the object is placed at 2F. So let's take a look at this ray diagram for concave lens. This is case 1 where the object is beyond 2F. So the image is formed here. So this is the image formed. Let us now describe the image in terms of its location, orientation, size, and the type of image formed. So where is the image located? Okay, it's between F and V. Orientation of the image, is it upright or inverted? It's upright. Upright or erect. And it's upright because the image is formed above the principal axis. Now the size of image. Compared to the object, the size of image is smaller or reduced. Now type of image. Is it virtual or real? So it's virtual. Why virtual? Because we have used here extended light rays and these light rays meet at one point here. So the image is formed on the same side as where we can find the object. So it's in front of the concave lens. So this is case 2 where the object is between F and 2F. So you have an object here placed between 2F and F. And the image is here. So this one is the image drawn, the dark green. So what do you think is the LOST of this image? So looking at the image, it is formed between F and V. Orientation, upright or erect. Size of image, it is smaller or reduced. And then the type of image is, look at, we have extended light rays there. So this is a virtual image. So this is the description of the characteristics of the image formed by this concave lens. So have you noticed something? Now let's try more exercises. This time you prepare your pen, your paper, and your ruler. Okay. So I'll show you these convex lenses. where the object is placed at different positions. So you have here the case 3 object is between F and 2F. Case 4 here object is at F. And case 5 object is between F and V. Now different locations for the object placed in front of the convex lens. So you try to make or to construct your ray diagram for these cases. Do this on your paper, and I'll give you 20 seconds to do this. And timer will start now. Time's up. So, are you done constructing your ray diagrams? Let us now see if you have correctly done it. I will show you the correct ray diagrams for each case. So this is for case 3, case 4, and for case 5. Okay, so the image, for case 3, the image is formed here. So this one is the image. For case 4, the image is, I can't see an image here. Okay, so there is a note here, no image formed. And then for case 5, the image is somewhere here. Now, based on these ray diagrams, we can now fill in and complete the table on your activity 4. So let's do this. So we will try to fill in, complete the LOST for letter C, D, and E. So we will refer to the 3 diagrams that we have done earlier. So this was case 3, where the object is between 2F and F. So the image is here. So what would be the location of the image? So location of the image, we will write it here. It's beyond 2F. Okay. Now, how about the orientation of the image? Is it upright or inverted? So it's inverted. Okay, you can see it there. Now, for the size of the image, the size is, you compare the size of the image with the size of the object, it is bigger or enlarged. And then the type of image is real. Okay, so we're done with letter C. Let's now move on to letter D. The object is at the focal point or at the focus. So the image is nowhere to be found. So that means for all these, we can just write no image. Okay, no image is formed. So remember that when an object is placed at the focus or at the focal point in front of a convex lens, then no image is formed because we will have parallel light rays. And then for letter E, so the object is here between F and V. So image is formed here, somewhere here. So let's write the LOST. So the location of that image is beyond 2F. Okay, and what else? Orientation, it is upright. And then the size of the image, okay, obviously it's enlarged or bigger. And then the type of image is, since we have used extended light rays here, so this is a virtual image. So notice that the LOST of the image formed by a convex lens is not fixed. It is changing. The LOST depends on the location of the object to the lens. So how about if it's a concave lens? Now let's try this. So I'm going to give you one case for a concave lens. So case 3, object is at 2f. So this is the object placed at 2f in front of a concave lens. So on your paper, you draw or you construct a ray diagram for this lens and for this case. And I'm going to give you 10 seconds. Okay? So later on, we will try to compare your work and the correct ray diagram. So let's start. Timer will start now. Okay, time's up. Let us now compare your work with this one here. Try to check if you have done it correctly. So this one here, you have the object placed at 2f and the image is formed somewhere here. For example, so you have here an object placed at 2f in front of a concave lens and an object placed at f in front of a concave lens. Let's complete this table here. So on this table, you will write the LOST of the image formed by the concave lens. So location, that's L, orientation for O, size for S, and the T is the type of image. So let's take a look at letter F first. Location of the image is at 2F, so this one here. So let's take a look at the first diagram. So this one here is our object placed at 2F and the image is here. This one here, this is the image. So let us now write the location of the image. So the image is between F and V. How about its orientation? Okay, we will write upright because the image is formed above the principal axis. And then the size of the image is smaller or reduced. Type of image, again, we have extended light rays meeting. So there is a virtual image formed. Now, how about on the next example? Okay, we have your letter G where the object is placed at the focal point. So the object is here. It's placed at the focus or focal point. So the image form is here. So let's describe the image. Image location is between F and V. Orientation is upright or erect. Size is smaller or reduced. And then the type of image, again, there is extended light ray. Then we write a virtual image. So notice that at 2F, at the focal point, the LOST, the description of this image in terms of location, orientation, size, and type is actually the same. And that goes through for letter H when the object is placed between F and V. So we can just write here between images between F and V. It is upright, it is smaller, and at the same time it is virtual. So this only means that for a concave lens, the LOST is fixed. If we describe the image formed by a concave lens, it will always be between F and V, upright, smaller, and virtual. So I hope that you understand our lesson. So to wrap up the lesson discussed, let's take a look at these two statements. So let's just read all together. Let's start with the first statement. Let's read. In a convex lens, the image form will depend on the location of the object to the lens. Now let's take a look at the second statement. In a concave lens with an object placed at any location, the image is always between F and V, upright, reduced, and virtual. So please keep in mind these two key points. Again, to emphasize, remember that for a convex lens, the image form will depend on the location of the object to the lens. So it isn't fixed. The LOST is changing. While in a concave lens, wherever is the location of the object, the image will always be between F and V, upright, reduced, and virtual. I hope you get it. So now, are you ready for the quiz? I'm going to give you 5-item quiz, and these are all multiple choice type of questions. So each question, I have allotted 5 seconds for you to be able to think of the answer and write the answer on your notebook or paper. So before proceeding to the next question, we will reveal the answer, the correct answer. Are you now ready? Okay, so get your pen and your paper and let's start with the quiz. So first question, what is the location, orientation, size, and type of image formed by the concave lens in the ray diagram at the left? A. At F, inverted reduced real. B. Beyond 2F, inverted larger virtual. C. Between F and 2F, upright reduced real. Or D. Between F and V, upright reduced virtual. So which do you think is the correct answer? Okay, 5 seconds starts now. Okay, so let's reveal the answer. I hope you have already an answer on your paper. It's letter D, between F and V, upright, reduced, and virtual. So now we can proceed to the next question. Number 2, what is the location, orientation, size, and type of image formed by the convex lens in the ray diagram at the left? A. At F, inverted reduced real. B. Beyond 2F, inverted larger virtual. C. Between F and 2F, inverted reduced real. Or D. Between F and V, upright reduced virtual. So think of the correct answer. 5 seconds will start now. Okay, so let's reveal the correct answer. And the correct answer is letter C, between F and 2F, inverted, reduced, and real. Did you get it right? Now let's proceed to question 3. A convex lens forms a real image exactly at 2F. It is inverted and has same size as the object. Which ray diagram best represents the characteristics of the image? Let's show the 4 ray diagrams. So which one represents the characteristics of the image as stated in the question? 5 seconds starts now. Okay, so the answer is letter A. So this is the image that falls at 2F. It's a real image, inverted, and has the same size as the object. So your answer should be A. Is your answer A? Very good. Now let's proceed to question number 4. In a convex lens, the image form will depend on the location of the object to the lens. Is the statement true or false? A true, B false. 5 seconds. Okay, what's your answer? Is your answer correct? Let's see. The answer is letter A. Letter A, true. Okay, now let's go to number 5, and this is the last question. In a concave lens with an object placed at any location, the image is always between F and V, upright, reduced, and real. Is this correct? A yes, B no. I'll give you 5 seconds. Okay, so which one is the correct answer? Let's see if your answer is correct. The correct answer is B, no. Why no? Why do you think it's a no? It isn't correct. Okay, the word here real should be virtual. Okay, very good. So the correct answer there is no. It should be virtual and not real. How many correct answers did you get? If you get 4 out of 5, then you passed the quiz. Well done. Okay, now I think we're ready for the assignment. Okay, so for your assignment, you need to create a Venn diagram that shows differences and similarities of the two types of lens, convex and concave. Use one short bond paper, coloring materials, or any other materials that will help you create a Venn diagram similar to what is shown here. Okay, so this is a Venn diagram. So you will input uh, statements here, phrases, words that will relate the two types of lenses. So what you're going to do is you may follow this Venn diagram and the colors. Red circle is for convex lens, white circle is for concave lens, and the pink at the center would be filled by the similarities between convex and concave lenses. Or you may also use your preferred colors if you don't like red and white. Okay, other colors, it's okay, as long as it's a Venn diagram. Now, rubrics for rating, content is 6 points, craftsmanship is 4 points, and this is a total of 10 points. Again, this is Mom April, and greetings to all. May you have a very good day and happy learning.